Right. So as the Augustine mentioned, we have announced the Aspire as well. So we're using Aspire on all lots of the awesome cool features with .NET 8. So we are you can register this .NET Hack Together hackathon right after this .NET conference from November 20th. So they check the URL behind aka.ms/hacktogether/.NET. Right. So I will introduce the Aditya for the next session. So hello, Aditya. How are you?
Hey, Justin. I'm so good and really, really happy to be here for .NET Conf this year. How are you doing?
Yeah, I know. So I know we've done together a few Let's Learn .NET session before. So I'm looking forward your topic. So are you ready?
Yes, definitely ready and excited, and I really hope this goes well.
So over to you.
Awesome. Thank you so much. Well, hello everyone. Hope you're all doing well. If you're in India along with me right now, a very good morning to you, or you know, time zones around. And if it's evening for you, good evening. First of all, a huge thank you and shout out to every speaker who's spoken at .NET Conf before me. I've been watching a lot of the talks, and these announcements have been absolutely exciting. I'm going to be talking about a space that I've been involved in for a little while now, around APIs and certain ways of securing your APIs. So the talk that I have will be focused specifically around role-based access control and how you can implement that within ASP.NET APIs. Just before I jump into the same, I can introduce myself once. So I currently work as a developer advocate at Appright, which is an open source backend as a service platform. I've also been a Microsoft MVP for the last year or so now. And if anyone would like to connect with me, my Twitter and LinkedIn are available on the screen right now. Coming to the talk itself, as we talk about understanding how role-based access control works and how it can be implemented, there are a few concepts that I will be focusing on prioritizing and discussing as we go through this particular talk today. The first one, of course, is role-based access control, or RBAC. The second thing that we will heavily focus on are JSON Web Tokens, or JWT. And thirdly, of course, this wouldn't make sense for .NET Conf without this, but we will be talking about ASP.NET Web APIs. So all the concepts we discussed will be shared centered around these three particular technologies. And we will be going further into each of these concepts as we go through my talk today. So the first thing first, as the title suggested, we should spend some time understanding what role-based access control is, right? So role-based access control is a security model that restricts system access based on roles assigned to users within an organization. What this means is that this access control methodology provides a way to manage user permissions by associating users with specific roles and granting them access to resources on this basis. Now, of course, this does sound quite fancy in an overview, but to simplify this, I think one of the best examples we can have is, let's take a WhatsApp group chat. If anyone has used WhatsApp and you have tried a group chat in the past, what you would have come across is that each group chat has, of course, your regular users and administrators. So while, of course, users get access to all the necessary functional services such as sending messages, reading messages, uploading images, or so on, administrators also get additional tooling, such as the ability to create invite links and the ability to change the description of the group icon, as well as the ability to restrict certain functionalities for regular users. This is effectively what role-based access control means and what it allows us to achieve with our applications and systems. Now, there are several pros and cons, of course, to this role-based access control methodology. Some of the pros that we have are as follows. RBAC, or role-based access control, follows the principle of least privilege. What this means is that this methodology allows organizations to enforce this particular principle by giving users minimal access or permissions needed to perform their responsibilities. This reduces the risk of accidental or deliberate misuse of permissions. Secondly, role-based access control is a particularly simplified permissions management solution. It allows management of user permissions simply by adding, removing, or altering roles on a user. And of course, you can apply the same to each resource or functionality. So as long as there is a role match between both the user and the resource, access is allowed and enabled. This is a relatively simplified method, so it helps streamline administration of permissions as well. It allows a lot of consistency in access control for all users, because when you apply access of a certain role to a resource, this access is consistently provided to each user with this role. This sort of consistency and standardization allows consistent implementation of security policies as well. Because you can have distinct roles within this system, role-based access control also allows much easier auditing. This helps ensure compliance with regulatory requirements as well as it helps in identifying any deviations from the norm, which could indicate a security issue. Because users receive a specific set of access rights when they assume a particular role, this enables them to perform their duties effectively without encountering access-related delays. RBAC also enables increased operational efficiency for an organization. And because all of this is effectively achieved by adding or removing a single role on a user account, it also helps assign or revoke access as necessary. This does make the process far more efficient. Because, of course, RBAC is achieved by clear definition of roles. This helps segregate duties based on role and responsibility, thus ensuring that you prevent conflicts in assigned tasks as well, which can help prevent further error and fraud. And yet, of course, being an access control methodology, because you can control who has access to data and resources, organizations can far better protect their confidential and personal information and its privacy. Of course, these are some pros of role-based access control, and with all of these pros, there are going to be a few cons in the process as well. So some of these cons include initial setup complexity, because of course you can have a large number of roles in a certain organization. Defining these at an initial level can be a particularly complex and time-consuming process for an organization, especially for larger companies and orgs where you have a massive number of users as well as a variety of levels within access requirements. What this means is that a lot of times there needs to be a lot of understanding and planning of processes before a role-based access control system can be implemented. Secondly, with larger organizations, or if you have a system which can have very complicated access needs, the number of roles can quickly keep growing and growing and growing, to the point where this becomes unmanageable at times as well. Thirdly, role-based access control, while of course simple, is not very flexible in dynamic environment controls where user responsibilities, tasks, access needs can continuously keep changing. it can become cumbersome to continuously create new roles or so on. So there is a concern, especially if you have a highly dynamic organization environment. Then, of course, there is the maintenance overhead. For any large org, there is a continuous requirement and a need to review roles and responsibilities to ensure that they reflect the current job as well as organization scenario. And this, of course, can be resource intensive for an organization. Standard role-based access control does not handle granular access very well. There is a lack of granularity here, which can be necessary for certain applications and systems. Now, of course, this particular aspect, the lack of granularity combined with needs for flexibility, led to the development of more granular methodologies such as attributes-based access control or policy-based access control, which you can consider based on your scenario or need. And yes, RBAC is only effective when roles are defined in a very accurate scenario. If there is a circumstance where roles do not accurately reflect the organization's operations, users will not have the appropriate access needed to perform their responsibilities. Now, these were some pros and cons of role-based access control, and you can take these into account as you evaluate whether this access control methodology works well for your system or not. It is well proven, tried and tested, so you can definitely consider it as you go forward. Within ASP.NET Web APIs, the simplest way to implement this particular access control method is by using JWT-based or JSON Web Token-based authentication. Now, as I mentioned, JSON Web Tokens or JWT, what does this really mean? JSON Web Tokens are an open standard that defines a compact and self-contained way for securely transmitting information between parties as a JSON object. This information is digitally signed as well, by the way. So it can be verified, therefore creating a scenario with trust. One interesting thing about JSON Web Tokens is that they are stateless. So the server itself does not need to store any token information. This allows JWTs to become scalable and suitable for client-server applications and distributed systems alike. When we talk about a JWT, of course, each JWT or a JSON Web Token has three parts. They're all they all comprise three parts. The first part of a JSON Web Token is its header. This header typically consists of two primary information. The first is the token type, which in this case is JWT. And the second is the signing algorithm used, such as the HMAC, SHA, or the RSA algorithms. This is necessary because the algorithm mentioned here will be used to verify the signature as well. And yes, the header is base64 URL encoded. The second part of a JWT is its payload. Now, the payload contains claims and statements about the user or entity. Claims can include information such as the user's ID, their personal information, such as their name, their email, etc. It can include their roles. It can include any other permissions, as well as other relevant data like expiration time of the JSON Web Token, the issuer, and so on. It is also base64 URL encoded. The third part of a JWT is its signature. And this signature is created by taking the base64 encoded header, the base64 encoded payload, and a secret key that is only known to our server. And we combine these three and apply the signing algorithm on top of it. So this signature helps ensure the integrity of the token, and it can prevent tampering as well. The way servers validate JWTs is that when you send your server or your API here a JWT, before the server enters the specific action or functionality that you want to leverage, the server decodes the JWT to extract the header and payload. First thing. Second, the server verifies the signature by reapplying the signing algorithm used to the header, payload, and secret key. The server then checks the expiration time in the payload to make sure that the token is not expired. And of course, before this, as it's reapplying and verifying, in case the recalculated signature does not match, the server can evaluate that the JWT has been tampered with. After this, there is an expiration time check, as I mentioned. And following that, the server may perform additional checks, such as verifying the token issuer, the token audience, and any other such information. Like, for example, if there is an additional check, such as comparing it with a list of revoked tokens or so on. This allows your server or your system to further secure your application. In general, this is the standard process for validating and verifying any JWT-based system. Now, when we implement RBAC in ASP.NET via JWTs or JWTs, there are a few things to keep in mind. The roles we have are set using claims within the payload. ASP.NET Core has an authorization middleware that it offers out of the box that can check and verify these claims and make sure that the role is present. This is applied in a very simple method by mentioning the authorize attribute with the role to any action or controller. One thing to keep in mind is that this sort of role-based system, the attribute-based system, is specifically applied on controllers and controller actions. In order to achieve this in minimal APIs, you will have to create a policy and include the role within that. For now, that is the only way really to have a role-based check for minimal APIs, which isn't necessarily a bad thing. Policy-based or access control has a massive benefit of flexibility there. But if you want to apply simply the role attribute, that is for now restricted to controller-based systems. One interesting thing about RBAC and ASP.NET is that you can achieve this without using the ASP.NET Core identity library. Now, the identity library has been available for a little while now, which features a number of facilities, such as the ability to have identity choosers, identity roles, and the ability to generate identity endpoints as well. In this particular talk, however, the sample that I will be showcasing and developing after this will not be using ASP.NET Core identity, primarily to help further discuss and delve into how the process of verifying and checking JWTs works. But that being said, you can always use ASP.NET Core identity in your solutions. So now that we've discussed what role-based access control is, how JSON Web Tokens work, and how these are implemented within ASP.NET, let's look at a little demo. Now, for this demo, I have already prepared a project that you can view on GitHub, or you can clone and check on your local system as well. The project is available on GitHub at the repository on my screen. You can either type in the link that is shown or scan the QR code. I am, however, going to be switching over to Visual Studio now. So I have already cloned this project for my particular local device, and I'm going to be rebuilding this, of course, as we go through the talk. So I have prepared a number of snippets for myself to showcase the logic that we have available for this. One thing to note, there are a number of packages that are going to be, and these are NuGet packages that will be installed along with this particular project. Before I jump into the project itself, I will talk a little bit about these. So the packages that we have here, the first one is an argon2 library. Argon2 is a hashing algorithm that is used to hash passwords as you store them. It is considered one of the most secure hashing algorithms for the purposes of hashing passwords. Therefore, I included a library that lets me implement argon2 out of the box. Next up, we have the ASP.NET Core Authentication jot bearer library. And this will allow us to add the necessary middleware to verify and check jot-based bearer. It'll allow jot-based bearer authentication for us. Then, of course, I have the Entity Framework Core in-memory library, which lets us set up an in-memory database for the quick purposes. And we're going to use this because we will need our logic here to store user information and so on. You can, of course, in production applications, use any other database or ORM here as well, if you'd like. And lastly, of course, you see the Swashbuckle library, which is used in ASP.NET to set up a Swagger UI. Now, next thing we're going to do is we'll go take a look at our program class for now. Now, with this program class, I have already marked out certain steps that I have that we will be following along as we go forward today. This, by the way, is a class that builds our web application, registers any necessary services, and so on. So the program.cs class, it will be essential here for us. We've got our user model available here. And this is user model that I've created for now. You can, of course, create a custom model for your own solutions as you like. My model here will include a username, a name for the individual, the list of roles. There will also be an is active field, the token, of course, and, well, the password. I've also created login user and registered user classes, which we will primarily be using for input on the different controller actions we have. That's primarily what these will be used for. We've got our controller and we've got our database context, of course, and the auth service aside from that. So first things first, as we talk about our users, right? The first thing I want to do here is make sure that our users can be added to the database and that this, of course, can be used along with us. So I'm going to go forward to the database context class that we have. Now, for anyone who's used to working with C# and .NET, this should feel familiar enough, where we've got a little database context and a DB set that we're using for communication between our web API and the in-memory database. One little additional function that I will, however, add here is an on-model creating function. The reason we need to add this particular function here is because when we work with in-memory databases or SQL Server and this particular and the in-memory database do not have an out-of-the-box ability to store lists or arrays of strings. And I do want to use this because we will be using, and we want to have the ability to store multiple roles for each user as well. Next up, once we do this, we've got our database sorted. So I can go ahead to my program class and we can register the database context here. So I'm going to go ahead and register the database context so that we can use our database. Next thing, after our database is registered, I will go ahead to the authentication service I have. I have my interface, which features just a login and a register function here. And it also, I am injecting the database context as well as the configuration here, because I will be using our configuration to get our secret key, our issuer, and our audience. As I go back to the service that I have, the next thing I'm going to do here is, of course, set up a search for this process. Just make sure that we're able to check for our user in the database and verify the password here. So I'm going to go ahead and implement a user check. We'll be using the database context to just find for the username, because the username is set as the key. We will then be using the Argentoo library to verify our user password here. Once this is done, we will then go ahead and create our JWT token handler and get back the security key, so that we can then go ahead and start, well, preparing our token as well. We will need the key to prepare the token. We will go ahead and prepare a list of the user claims we need to leverage here. Now, one thing I have done, if you notice, is that I have additionally added a for each loop to add all of these different roles. This is primarily why we're preparing the list of claims outside of, well, the rest of the token as we see it. Next thing we will do here is we will prepare a token descriptor. This here defines the structure of our JWT token, particularly what claims we will have and any information about the same. So as you can see, we're using the configuration to get the issuer, the audience information. We're adding our expiry. The signing credentials features which security algorithm we're using. And we've prepared our key beforehand already. So that's that. And lastly, we will create our token finally, now that we have our token descriptor, and we will use the token handler to write this token. We'll also quickly add the functionalities that we use to register a certain user, which is basically the same as hashing the password and adding it to our database in the meantime. But as I mentioned, as we discussed the process of preparing a JWT, this service here is the login service particularly features all of this logic here. Once this is done, I will quickly go ahead back to my program class, and I will register the auth service here firstly, as well as add the configuration for our JWT bearer token. This is where we need the ASP.NET authentication JWT bearer library, because this will be used when a JWT is sent is sent for authentication to the API as a part of the headers. So this features the authentication scheme and the challenge scheme here for us. And then we have a set of options that it can have. We set the required HTTPS metadata setting as false for now, because this is a project in a development environment. For production environments, please make sure to keep this as true. Then, of course, we've got our token validation parameters, which will be used to verify the token. So if you notice, we will be validating this with the same issuer and audience as we used to create our token. This is very, very important, because not having a mismatch would imply that a token is being issued or received by someone it is not intended to. Therefore, these validation tools make sure that a token is being accepted and leveraged by the necessary individual. And of course, we verify the signing key that we used to generate the signature. One last thing that is left with the program class that I will quickly add for now is add the necessary Swagger generation. And I'm not going to get too deep into this, but this essentially adds a security definition to allow bearer-based authentication within your Swagger UI. This isn't mandatory for the functioning of the API itself, but particularly helps make life easier when you're testing this API. Lastly, we'll go down to our controller here. For the login controller, I will quickly go ahead and add the necessary, the login logic. because we've already got our auth service and it's been registered here, this is a fairly quick process at this point. And we will add another piece of additional logic here before we return the response, which is a null check. The reason we do so is because if you check in the auth service, we are returning null in case the user is not found or in case the password is added incorrectly. So this way, you can return a bad request if necessary. We'll quickly similarly add the registration logic, which allows you to register a certain user and add similar checks there. Additionally, as you notice, for our test action that we have, which lets us apply a certain role, as I mentioned earlier in the presentation, we use the authorize attribute for this purpose. For this function, all I'm going to do is I will be getting back our request header, grabbing the token from it so that we can check what claims are available within this. So what I will be doing here is that I will just be getting back the token that we have and grabbing a list of claims from it and returning it back to our user. So once this is done, first thing I will do quickly is, well, add my name, add a username. And by the way, for username and password, you can define further logic to add a check on what kind of password validation you'd like. You can do that in the future. There is a lot of scope for custom validation here. So as I've registered the user, you can see within the response that a password has been hashed. Ideally, you should not be returning this. I am only doing so at the moment to showcase how the hash password looks. We'll go forward and use the same, username and password for us to, verify and get back a certain token. So as you can see, a token has been generated, and we'll quickly do one thing. We will add this here within the available authorizations, and we will use this to try out and see if our role-based access works. And as you can see, it does. We are able to get back our particular the claims for this particular jot. Now, if suppose I was to change this up and not have the same role, let's say, for example, I have now got a user with the role general, and I log in with this particular user this time, and we take this token, add it to our authorization here. What we will now see ideally is that the test function should not work, which, as you can see, we get a 403 error as expected. So that is how you can implement role-based access control within your application. Now, a couple of things you should do, of course, post this talk if you want to build this from scratch is please download .NET 8 and grab Visual Studio. They are the ideal environments for you to continue building .NET applications. Although if you're not on a Windows environment, like for example, if you're in a Linux environment, you can also use VS Code along with the C# dev kit to do so. And that is about it for me. Do we have any questions at this point?
Thanks, Aditya, for your awesome sessions. I'm checking in the chat if there is any questions. No. So, but your session, I love your session, and a lot of thanks for your insight sharing. So Again, thanks for your session, Aditya. I will see
you.
you next time.
All right, then. Take care, everyone. Bye.
Bye-bye.